So now we want to look at some more problems involving mixed fractions where denominators are different. So let's look at this problem. 2 1/3 plus 1 1/2. Now the way there are several ways we can approach this problem. We can break up the 2 and the 1/3. We can break up the 1 1/2. But I prefer to just convert these mixed fractions to improper fractions. So we have 3 times 2, that's 6, 6 and 1, that's 7. So 2 and 1/3 written as 7/3. And 1 1/2 we can rewrite as 2 times 1, 2 plus 1, 3/2. So now we're adding 2 fractions here, 7/3 plus 3/2. And of course, as you just learned in the previous video, we cannot add them unless the denominators are the same. So we go for the LCM, which is 6. So now we need to rewrite both fractions as a value over 6. So we look and we say, okay, what can we multiply? What can we multiply this 3 here to make it become 6? And that's obviously 2. And of course, whatever is done to the denominator, the same has to be done to the numerator. Now we come over to this fraction. We want the denominator to be 6. So we ask ourselves, what number can we multiply to this 2 to make it become 6? And yes, you guessed correctly. That number is 3. And of course, whatever is done to the denominator, very important, don't forget, the same has to be done to the numerator. So we also need to multiply this numerator by the same value, 3. So, the first fraction, 2 times 7, that's 14. 2 times 3, that's 6. Plus 3 times 3, that's 9. And 2 times 3, that's 6. So, now we can go ahead and add both numerators. 14 plus 9, that's 23 over 6. And if you wish, you can always rewrite this as an improper fraction. 23 divided by 6, that's how much? 18? 23 divided by 6, that's 3. And 5, 6. Good? Let us look at another example. Let's say we're asked to compute 4 2/5 minus 2 and let's say 2/3. Again, convert both fractions to improper fractions. So 5 times 4, 20, and 2, that's 22. And 3 times 2, that's 6. 6 and 2, that's 8. So now we need a common denominator. And the LCM for 5 and 3 is 15. So we need to make this, turn this 5 into 15. So we ask ourselves, what can we multiply the number 5? What can we multiply to 5 to get 15? Yes, that's 3. Remember, we have to do the same thing to the numerator. In the same way, we want this denominator to become 15 also. So we ask ourselves, what can we multiply to this 3 to make it become 15? And yes, that's 5. But again, the same has to be done to the numerator. So 3 times 5, that's 15. 3 times 22, that's 66. And then over here, 5 times 3, that's 15. 5 times 8, that's what, 40. So 66 take away 40, that's what, 26 over 15. So we can go ahead and subtract numerators because now we have the same denominators. Let's look at a couple more examples. So, what if we're computing, say, 4 minus 8 over 5. So again, remember that 4 is itself over 1. Since we make it into a fraction, since we are subtracting a fraction from it, so we can make it into a fraction. Any value can be written as itself over 1. And so, the LCM for 1 and 5 is of course 5. So before we can subtract, we need to make denominators the same. And therefore, we need to turn this 1 into a 5. And what can we do to turn it into a 5? Multiply it by 5, of course. But because we multiply the numerator by 5, and you get the gist by now, you also have to multiply the numerator by 5. And remember, multiplication is commutative. The order is not important. So if I put the times 5 to the right or times 5 to the left, it doesn't make a difference. 5 times 1, 1 times 5 is same 5. Alright? And likewise, 5 times 4, 4 times 5 the same 20. Now for this one, we need also for the denominator, well, it's already 5. So, it's already 5. So we are okay there. I don't need to trouble it. Alright? So 4 over 1. And by the way, just observe, what's 20 divided by 5? It's 4. But we conveniently write the 4 as 20 divided by 5. Because we need it to have the same denominator as 8 over 5. So that we can go ahead and subtract the numerators. Alright, so we can group the numerators over the same denominator. So 20 minus 8, that's 12. 12 over 5. And if you wish, you can always convert it to a mixed fraction. 12 divided by 5, that's what, 2? With a remainder of 2. So 2 and 2/5 would be the equivalent. Of 12 over 5. Let's look at another problem. Three and a half minus 1 and 7/8. So now we can convert each of these fractions into improper fractions. So 2 times 3, that's 6. 6 and 1, 7. So this becomes 7 over 2. 8 times 1, 8. And 7. 8 and 7 is what? 15 over 8. So again, we cannot subtract the numerators. Why? The denominators are different. So we need to make both denominators the same. And we consider the LCM for 8 and 2 is what? 8. So we need this 2 to become, we need to change, convert the denominator of 2 to a denominator of 8. And how can we do that? We can multiply it by 4, of course. And we need to do the same to the numerator. Alright, so 4 times 2, that's 8. 4 times 7, that's what, 28. And this 15 over 8. So now we can go ahead and subtract numerators since the denominators are the same. So 28 take away 15, what's that, 13? So 13 over 8. Or if you want to convert it to a mixed fraction, 8 goes into 13 one time, leaving a remainder of 5. So our solution there, 1 and 5 over 8.